Hey guys, and welcome to another video of teaching knockoffs. Last video we covered organic compounds and alkanes, alkenes, and alkynes. Today we're going to be moving on to the aromatic classification and the oxygen compounds. But before we start, we always have to give knockoffs for safety. So we're going to give her her safety goggles. She needs to lock in. So aromatic classification is what we're going to start with. So with the aromatic classification, there is aromatic compounds. And the one that we're going to be talking about today is called benzene. Benzene. So benzene is basically a ring of 6 carbon atoms, each bounded to one hydrogen atom. The only thing that makes it different from, for example, in the last video we talked about cycloalkanes, is that instead of it being called a cyclohexane, it's called a benzene because it has alternating double bonds. So a benzene is going to look something like this. So we have our 6 carbon atoms, and then we're going to have alternating double bonds. So we have a carbon atom here, here, and then we're going to have these alternating double bonds. And that's what makes it a benzene instead of a cyclohexane. So with benzenes, we can draw it out like this, or we can simply draw it out like this, with just a circle in the middle. So either way, this is a benzene, and this is also a benzene. Now, there's examples of benzenes. So, first one we're going to talk about is what we call a phenol. So we haven't went into alcohols yet. That would be the oxygen compounds, but we're just going to introduce it now because it's a benzene. So, let's do a different color. Let's do phenol. So a phenol is when we have a benzene ring, okay, and then we have a hydroxy group attached to it. So a hydroxy group is basically a OH group, and we're gonna see in later that this is what makes alcohol compounds, and it also will make sense later why it ends with O, why phenol ends with O. So this one, the name for it would be, since we have an alcohol, again, we'll go more into it, but the prefix for our alcohol would be hydroxy. And then we just finish the name with benzene. So when it comes to naming benzene, it's just going to be, like we said in the last videos, the substituent number if you need to, and then instead of having to count the carbon atoms and go look at the prefix chart, we just put benzene at the end of it for now. So let's say we have a different kind, which would be aniline. Aniline would look something like this. So it's a benzene ring, but instead of a hydroxy group, it's going to have a nitrogen group, NH2. And this would be called amino benzene. And then we have another example, which would be our toluene, or toluene. And it's basically when we have a benzene ring with a alkyl group attached to it. So this one's pretty common. We're going to see it a lot. And the name for this would be methylbenzene. Methyl because the substituent is only one carbon, and then benzene because that is the ring that we have. And then finally, we have what we call a phenol. And a phenol is when the benzene ring is our substituent. So say we have a carbon chain like that, and the benzene ring is going to be a substituent, like right here. So it's not part of the main carbon chain, it is a substituent. So like we said, when it comes to naming, it's always going to be 6 carbons, so it's always going to be benzene, and then substituents given to the least number. So let's do an example of naming a benzene, but let's bring log-ops here. Perfect. So let's say we have something like this. We have our benzene ring, and then we have, say we have a chlorine group here, chlorine group here. How would we go on about naming this? So we know that's going to be a benzene because we have our benzene ring, so that one is easy. Benzene. And now we're going to look for our substituents. So we see we have 2 substituents, and they're of the same group. So in the last video we mentioned that if they're in the same group, we use di-tri prefixes. So we have 2 of them, so it's going to be di, and then they're chlorine, so dichlorobenzene. Let's move this closer. Dichlorobenzene. Are we done? No, we're not, because we need to number our substituents. So the lowest position would be if we did this: 1, 2, 3, 4, 5, 6. So that would mean that our chlorine groups are at 1 and 2. So we just have to mention their positions. So this one would be 1, 2 dichlorobenzene, and then let's do one where we have a alkyl group. So let's go with a benzene ring like that, and say we have 1 here and 1 here. How would we go on about naming this? So we automatically know it's benzene, and then we're just going to look at our substituents. We see that they're alkyl groups, and they're each only 1 carbon, so that makes them both methyl. But since we have 2, it's going to be dimethyl. And then we just have to say their position. So instead of going 1, 2, 3, 4, 5, 6, which will give us 1 and 5, that's not the lowest possible substituent. We'll go 1, 2, 3, 4, 5, 6. That way our numbers are 1 and 3 and not 1 and 5. So we're just going to say that. And then our molecule will be called 1,3-dimethylbenzene. So that is benzenes. Next thing, we're going to talk about the organic compounds of oxygen. So the organic compounds of oxygen are going to be our, let's use orange. They're going to be our alcohols. Whoa. Our phenols. And then our thiols. So we have our alcohols. Let's start there. And we had an example up there, but it basically just contains an hydroxyl group. An OH group, also known as a hydroxyl group. So, for example, if we have something like this, this would be an alcohol because it has that hydroxyl group. And with alcohol, the names are always going to end with "ol" and have that "ol" prefix. So if we wanted to go name this one right here, we have 1 carbon, which makes it meth, and then our alcohol group, so it's going to be methanol. So one more thing about alcohols is that there's 3 degrees to the alcohol. So a 1 degree alcohol would be attached to 1 carbon group. Only attached to 1 carbon group. A 2 degree would be attached to 2 carbon groups, and then a 3 would be attached to 3 carbon group. So let's do the 3 carbon group. So we'll do an example of each. So a primary or 1 alcohol would be if we have our carbon atom here that's attached to 2 H's, and then our group right here, and then we just have our OH right here. So we see that OH is only attached to 1 carbon group. This doesn't count because it's not a carbon group. This has the full CH3 with it. So this is only attached to 1 carbon group. A 2 alcohol would look like this. Instead of a hydrogen up here, we have a carbon group, and then our hydrogen down here. So I'm just going to highlight this is 1, this is 1, and 2. So this would make it a secondary alcohol because the hydroxyl group is bonded to 2 carbon groups. And then finally, our 3 alcohol would look something like this. So be our carbon, our hydroxyl group, and then 3 carbon right here. So we can see that the hydroxyl group is connected to 3 carbon groups. So that makes it a 3 alcohol, or a tertiary alcohol. So we'll just number those 1, 2, and 3. So that's the classification of alcohols. So let's do some examples with naming alcohols. Let's say we have, we'll do it right on top. Let's say we have something that looks like this. What would this be? So automatically we know that it's not benzene because it doesn't have the circle or the alternating double bonds. So this is just going to be a regular cycloalkane. So we know that the end name or the parent chain is cyclohexane. Hexane because we have 6 carbon molecules, and if we go up to our chart, we see that 6 is hex. And then we need to change the prefix because it's no longer an alkane, it's an alcohol. So we're going to erase that. Hexanol. So that would be our cyclohexanol. Now, what if we have something like this? So, what would this be called? So we'll start by counting how many carbon atoms we have. So we have 1, 2, 3, 4, 5. So we know that this is going to use the pent prefix, and it is a cyclic compound, so it would be cyclo hex. And then we see the OH group, we know that it's going to be an alcohol. 5 would be pent, so it would be pentanol. So our parent chain would be cyclopentanol, and then our substituents that are attached to the carbons, we have our alcohol, which we already addressed, and then we have this one. Now when we talked about numbering, we said that we want the lowest substituent. So logically we can go 1, 2, 3. We can start at this one. But no, when we have an alcohol, our number 1 substituent is always going to be our alcohol, no matter what. So alcohol will always be 1, and then the substituents come after. So we always start at alcohol and go after that. So our substituent would be on the second carbon and it is a alkyl group. So we will count how many carbon atoms there is here. We only see one carbon here, so that would be a meth. So it would be methyl, and it's on the second carbon atom. So this name would be 2-methylcyclopentanol. Perfect. Now, let's do a phenol example. What are phenols? So phenols are when we have our amazing benzene that has a hydroxyl group attached to it. So let's name it. So let's say we have this. This on its own is called a phenol. But let's add some jazz to it. Let's add a chlorine right here. What would this be called? So we know that this parent chain is called a phenol. So it's just going to be phenol. We're not going to count anything. It's just phenol. A benzene ring with a hydroxyl group, automatically phenol. Now we have to address our substituents. So we have a chlorine. And remember, when we want to number our substituents, we always start with 1 at the hydroxyl group and then move from there. So that means that our chlorine is going to be on the 3rd carbon. So it would be 3 chlorophenol. 3 chlorophenol. Let's say we have something like this. Our benzene ring. We have our OH group. But then down here, we have something like this. Or actually, let's draw it like this. So what would this be? Oh, let's do it like this. What would this be? So let's identify what our parent chain is. So we see a benzene ring, and then we see a hydroxyl group. Automatically know that that's going to be a phenol. Then we're going to see, oh, we have a substituent. So let's number our chain. We always start with alcohol as number 1. 4, 5, 6. So we see that our substituent is is attached to that 4th carbon. Now we want to identify what our substituent is. So we see 1 carbon, 2 carbon, which means that this is ethyl. So for our final name, we are going to put the position of the substituent. So it's 4. And then what the substituent is, it's an alkyl group, and we have 2 carbons, so it's going to be ethyl. So this would be called 4-ethyl phenol. So that is our ethyls. And then finally we had our thiols. It's just basically when the carbon chain contains an SH group. So it would look something like this. That's it. Alright, moving on to our other oxygen organic compounds, which are going to be our ethers. So let's grab Nogops and bring her up here so we can do some ether. So ethers. What are ethers? Ethers is when you have a oxygen molecule in between 2 R groups or carbon groups that are either alkyls or aromatic rings. So for example, if we have this one right here, we have our oxygen, and then on either side of the oxygen, here we have 1 carbon group. Here we have another carbon group. So how do we go on about naming it? We're going to name one group, and then we're going to name the other group. So the first group, we're going to see that has one carbon atom. So this would be, it's going to use the meth prefix here. And then this one also has one carbon atom. So it's going to use the meth prefix too. And then when it comes to naming them, there's going to be two names. For now, we're going to just go with that one being methoxy and this one just being our regular alkane. So we're going to have the final name of methoxy methane. What that's telling us is that on either sides of the oxygen, we have methyl group and a methyl group. So let's do one more complicated. That makes a little bit more sense. Let's say we have something like this. So and we have our oxygen and then our carbon group right here. So automatically we know this is an ether because when we see that oxygen surrounded by two carbon groups, we know it's an ether. So how would we go on about naming this? So what we should start by doing is by separating the groups on either side of the oxygen. So we'll start with this group. This group right here is our, let's use black, is our eth group. And this group right here is our, let's use purple, meth group. So we have one carbon, so meth, two carbons, eth. So now we gotta know which one gets the oxy and which one gets the ane. So the shorter side always gets the oxy ending. So whichever side is the shorter one, the one that has the least carbon atoms, gets the oxy ending. And then the longer side gets your regular ane ending. So our shorter side is going to be methoxy, and our longer side is going to be ethane. So to put this together, we're going to arrange them in alphabetical order. So our final name is going to be no, sorry, these do not get arranged in alphabetical order. You put the oxy group first. So methoxy, and then you put your alkane group, ethane. So this would be called our methoxy ethane. So let's do an example. Let's say we have something that looks like this. And then we have oxygen. Something like this. What the hell is this called? So let's bring knockoffs. Perfect. Yep. So, what would this be called? Let's start by counting the carbons on either side of the oxygen. So in this one we have 1, 2, 3, 4, 5, 6, 7, 8. And then on this one we have 1, 2, 3, 4. So if we have 4 on that side, hold on, made a little mistake. This one would be 7, and this one would be 3. So if we have 7 on here and 3 on there, what would this one be called? So let's count 7 and 3. So we said before that the shorter side always gets the oxy prefix, or the oxy ending. So this one has 3, so it's going to have the prop prefix, and then we just add the oxy ending, so propoxy, oxy, and then the longer side is going to have the regular ane ending. So 7 would be heptane. Putting it together, we put the oxy first, so epoxy, heptane. Just like that. And one more thing that we need to know is we need to add a 1 to show that the location of the O, where the location of the O is on that longer chain. So it would be 1, 2, 3, 4, 5, 6, 7. It would be connected to number 1 for the longer chain. So if we go back here, we would also have to put a 1 here to indicate that it's on the first carbon of that longer chain. So those are our ethers. Now I'm going to move on to what we call the carbonyl groups. So the carbonyl groups are going to be, let's grab Novops. Running out of space here. Let's bring her down. No, actually, let's go up here for our perfect. So our carbonyl groups are when we have, here, let's write it down. Carbonyl group is whenever you have a carbon atom that is double bonded to an oxygen. That's our carbonyl group. When we have a carbon atom that is double bonded to an oxygen atom. There's 2 types of carbonyl groups. We have our aldehydes, and we have our ketones. So aldehydes are going to be when you have your oxygen atom, it's too big, your oxygen atom double bonded to your carbon atoms. Then you're gonna have at least one hydrogen atom at the end of the chain, and your other side is going to be your carbon. So an aldehyde is when we have oxygen double bonded to a carbon, and then we have a carbon group on one side and an H group on the other side. And ketones are going to be when we have our double bonded oxygen with its carbon atom, but on either sides it's going to be a carbon group. So the simpler drawing of this would look like this, and the simpler drawing of this would look like that. So that's how you can tell the difference between a aldehyde and a ketone. Now, they each have their own naming rules, but let's look at their structural formulas and how they would look. So for like a aldehyde, you'd have something like this. Oops. Where should we do it? Let's erase this. Make some space down here. Okay, so let's say we have something like this. Let's split them up. And we'll start with our aldehyde. So this one would be our aldehyde. How can we tell that's an aldehyde? Because if we were to break this down, we'd end up with this. Because we have our oxygen, we have our carbon, we have our hydrogen, and they're bonded to a carbon group. So how would we go on about naming this? So we'll start by naming the longest chain. We see that we have 5 in this chain. So we'll number those. 1, 2, 3. Sorry, we have 4. 4 in this chain. So we'll number them. And then we're going to name it. So 4 would be bute. So that would be butyl. Bute. And then you replace that E with an al. So butanal. So instead of butane, butanal. It has that, let's put it up here, that al ending. So butanal. And with this one, we'd just be done here because we don't have any substituents. What butanal tells us is that we have a aldehyde in here, and we have 4 carbons. So let's go to let's bring Nogoffs down a little bit, and then let's do the naming for our ketones. So naming for our ketones would be, let's say we have something like this. So let's say we have something like this. So first thing we're going to do, count our carbon atoms. We have 1, 2, and 3. So you want to number the carbon chain starting from the end nearest to the carbonyl group, giving it the lowest number. So with this case, it doesn't really matter, but if we have an example where we have like 5 carbons and our thing is right here, actually no, that's a bad example. Our thing is right here. We wouldn't want to go 1, 2, 3, 4, 5. We want to go from the end nearest to that double bond with the oxygen and number it from there. So let's go back to this one. What would this one be called? So with ketones, we're going to use the prefix -one. So count the chain. 1, 2, 3. It's a propane chain, but instead of the E, we're going to replace it with -one. So it's going to be propanone. This chain is going to be our propanone chain. Prop telling us that we have 3, -one telling us that it is a ketone, where we have the carbonyl group with carbon groups on either sides. So let's put this together into something a little more complicated. Put everything together. Let's say we have something like this. Make that a little smaller. And then we have that double bond here. And then we have alkyl group right here. What the hell would this be? So first thing we're going to do, we're going to identify, is it an aldehyde or is it a ketone? This one, we have our carbonyl group. What's on either side? We have a carbon group and a carbon group. Let's see. Carbon group, that is a ketone. So we know that we're going to use the ketone naming rules for that. So we'll start by counting the carbons. We have 6, so it's going to be hexane, but we replace the E with a -one. So hexanone. And it is cyclic, so it's going to be cyclohexanone. And then all we have to do is identify our substituents. And similarly with alcohol, your number 1 would be your carbonyl group. So 1, 2, 3, you start counting from there. Again, we wouldn't want to go 1, 2, 3, 4, 5 because that would give us not the lowest number for our substituents. So 1, 2, 3, and that is an alkyl group. So we just count how many carbon molecules there are, and we see that there is 1. So it's going to be a methyl group. So methyl, and finally we have to put its position, and it's on the 3rd carbon atom. So this one would be called a 3-methyl cyclohexane. So that is our aldehydes and ketones. So actually, we'll do one more thing. Let's say you have an aldehyde, okay, that is a benzene ring. What would that be called? That would be called a benzaldehyde. So if we have our benzene ring and we have our carbonyl group attached to it with an H on the end, that would be our benzaldehyde. So let's move on to our carboxylic groups. So these ones are our carbonyl groups. The next ones that we're going to talk about are our carboxylic acids or carboxylic groups. So carboxylic acids, and what they are is they are basically a carbonyl group with an OH attached to the carbon in a carbonyl group. So let me bring our docs here. Come here. Perfect. So, oops, she lost her glasses. No, there she is. Okay. So, carbonyl group consisting of a hydroxyl group or a OH group. So we have our carbonyl group plus our OH in the R position. So what does that mean? It means we have our carbonyl group attached to the C. On that side we have another carbon, or we're just going to call it an R group. And on that side, an OH group. This makes it a carboxylic acid. We have our carbonyl group plus our OH on the side, giving us carboxyl group. So how do we go on about naming it? We want to identify the longest carbon chain, and then we replace the E with an oic acid. And so, by the way, I'm not going over common names because those are kind of their own thing. We're just going over IUPAC names. So we're gonna do our little example here. So let's say we have something like this. Let's do it up here. Different color, CH3 with C. Let me do it's a little bit thinner. Perfect. CH2 with our carbonyl group, OH attached to it, and let's jazz it up a little bit and add a CH group here. So where the hell do we even begin here? Where do we begin? So we're gonna start by identifying the longest carbon chain. We have 3 carbons, so let's start by numbering them, and we're gonna start numbering again similar to the alcohol and the carbonyl groups. We're gonna start numbering closest to the carboxylic group. So this would be number 1, this would be number 2, and this would be number 3. So since it has 3, we know that it's going to be a propane chain, but we said we're going to change the E and add oic acid. So propanoic acid. How did we know that we have to remove the E and add oic? Because we have a carbonyl group with an OH attached to it. So we know that it's a carboxylic acid. And then all that's left to do is to number our substituent. So we have a methyl alkyl group. So it's going to be methyl, and that's going to be on the second position. So this would be called our 2-methylpropanoic acid. Let's say we have something a little bit crazier, like, where do we even go now, Gobs? Let's go right here, this empty spot. Let's say we have something like this. Our benzene ring with our carbonyl group, carboxylic group. And then just for the funsies, we'll add Br down here. So, whoa, what would this be called? So we're going to identify our parent chain. We see that we have a benzene ring. So it's going to be benzene. But we have to replace the E with oic acid, since we see that we have a carboxylic group right here, carboxyl group. So all that's left to do is to identify our substituents. So we number closest to the carboxyl group. So 1, 2, 3, meaning that our bromine group is going to be on the third carbon. So let's just write that down. We have it on the third, and since it's bromine, we use the bromo prefix. So this would be called a 3-bromobenzoic acid. We're almost there. We have one last thing to cover, and that is our esters. So we talked about ethers a little bit ago, but now we're going to talk about our esters. Let's have this nice corner down here for our esters. So esters. Esters. Esters is when we have our carbonyl groups plus it's bounded to an oxygen atom. So it looks something like this. We have our carbonyl group that's bound to an R group, that's bound to an O group, that's bound to an R group. That is an ester right here. So how do we go on about naming these esters? The simplest thing we do is, like most namings, we're going to find where, hold on, let's write our example because this one can get a little bit complex. So let's say we have CH3, and then we'll have our ester right here, and that's bound to another CH3. So we're going to start by dividing these two groups into this group, and then this group right here. So this group right here is going to be our ethanoic, no, hold on. Yeah, there we go. There we go. Then we'll take the O over here. So if I were to rewrite this black one right here, it would be like this. Whoa, what is that? That's an alcohol. That is specifically methanol, because we have one carbon group, one alcohol. So we have our alcohol right here, and then we have, let's erase that, this right here. What is this? This is our carboxylic group, because if we also rewrite that, including that O, it would be like this. Yeah, like that. So this would be our acid, which would also be called, since we have 2 carbons, this would be called ethanoic acid. Ethanoic acid. So we have methanol and ethanoic acid. We have an alcohol and a carboxyl group. When you put those together, they're going to form your ester. So we're going to start by putting our alcohol, and then we're going to put our carboxyl group. So the name of this would be alcohol followed by this. But we're gonna name the alcohol as our alkyl group. So the first word is gonna indicate the alkyl part from the alcohol. So the alkyl part from the alcohol is just going to be our meth. And since it's an alkyl, it's going to be methyl. The second word is the carboxylate name of the carboxylic acid. So carboxylate is what we would consider this one. So it would just be, let's do blue. Ethanoate. So that would be how we would name our esters. So it has that 8 ending, and we used our alcohol group. We used the alkyl group from the alcohol group and the carboxylate name of the carboxyl acid. So we took the carboxyl acid and we added 8 to it. That would be our second word. So that is it for today's video. Aromatic classifications and oxygen compounds. I hope Nargops is still with us. I don't know if she is. I think she's long gone. But yeah, that's it.